Hey, welcome to the show. If you're just joining me for the first time, my name is Jacob Jewett, and this is my Q&A, and also, watching me while I actually record content. I'm a little late started, well, not a little late, but I'm just about there starting today. Had to do some adjustments to my chair. In previous live feeds, you probably heard some clicking noises, and I decided to take off the arms to my chair, like literally before I started the stream. So anyway, the other thing I got going on is I got a fly that's flying around here, and I swear I'm going to kill the thing. You can call PETA on me if you want, but it's driving me nuts. And so if I get the opportunity to kill this fly, you're going to more likely see me commit a murder of a flying, irritating, pesky, whatever you want to add to it. So anyway, I'm pulling up my chat right now so that if there's anyone that's joined, it is literally taunting me. That thing just flew in front of my face. I'm sure that you guys saw that. Anyway, so my thing is right. God dang, that thing is taunting me. You need to die. I'm going to kill that thing. It's going to die. So of course, once I pick up the fly swatter, the damn thing disappears. But anyway, let me get to where I can pull up my live chat here. Give me one sec. YouTube has changed the way your channel is laid out. They have this YouTube Studio, which is basically their beta. It's not that great, and they hid some stuff, so you kind of have to get there. Again, I'm sorry for taking a little bit longer to do this, but just trying to get to the live stream so I can see if there's any chat messages, and if there's anyone actually watching. That'd be kind of cool. So I got 0 watching. Yay. So I guess I'm the only one that's going to go crazy with this damn fly that will not leave me alone. Anyway, so if you've seen one of my videos before, you kind of know how it's laid out. I basically, talk about technology stuff and about how I'm going to create these videos, and I keep on lacking on them because I'm doing this as a side project, and really I gotta bring it more to the forefront. My plate is actually pretty full. I have a full-time job. I'm a salaried employee, and I work for a big corporation. I haven't gotten their permission to really say the name, on a live stream or on videos that I have posted. But I work as a security analyst for a major corporation, and so I spend a lot of my time doing that stuff, and I've been put in charge of implementing this new security, basically vulnerability system, to just make sure that we keep track of our vulnerabilities and do what we can to mitigate them. However, that's taken a lot of my time. And on top of that, since I've taken on a new role at work, I've also decided to go back to school and basically recertify and things like that. I've taught at colleges, at private colleges, and so I've always stayed up that way, and I've always, had my certifications here and there, but I never really kept them up to date. So with this YouTube channel, I am planning on, that dang fly, I swear, every time I put down the fly swatter, that dang thing, it's gonna die. It's gonna die. This is probably gonna be the most comical live stream ever because I am about to kill a freaking fly. It's so irritating. I will get that son of a bitch. Anyway, I will get. It's funny watching myself on the replay because of course it shows some of the video. Dang it. I will get that sucker. It will die. Anyway, so going back to what I was saying. So I've gone back to school. I'm actually, got it that time. Got it. I heard it hit and it's landed somewhere. It's going to die a very gruesome death. Just be my luck that someone from PETA is on here or something. The one time that someone actually watches my stream, and it'll be someone who cares about flies for some odd reason. Not to get political, but the funniest thing I ever saw was when Barack Obama was doing an interview with, I think it was 60 Minutes or something like that. And it was like in the first term of his presidency. And I just remember them airing the part where I guess a fly landed on his leg and he killed the fly. And it was national news that PETA was after him, or not after him, but complaining that he killed a fly on live TV and all that stuff. And it was stupid. I mean, I don't agree with a lot of politics on both sides, but there's bigger things to complain about than the death of a fly. I mean, if you're going to complain about the death of a fly, you might as well complain to frogs and everything else. But anyway, off of that tangent. You lived, you little bastard. I'm going to get that sucker. I swear, by the end of this stream, that sucker's going to die. Anyway, as I was saying, my plate's full because I've gone back to school. I'm going to Western Governors University. I'm actually in their cybersecurity and information assurance program. And I would say if you're going to decide to go to college, I would, they're not paying me to say this at all. And it's against the law for me to say that and them to be doing so. So, in all honesty, you son of a... I might get that thing fly. I swear. It literally goes across my eye line every 2 seconds. Anyway, so I'm going to, I don't get paid by Western Governors University to say this, but I've advertised them a couple of times. I've advertised them a couple of times, to friends and stuff like that. Just personal word of mouth. Oh my God, this is going to be a ridiculous stream. But anyway, personal word of mouth because I like the school. One of the reasons why I chose to go to Western Governors University myself is because they are a non-profit school. They're accredited across the nation, and they have the same accreditations as big name colleges. And it's you pay for time. So you pay for 6 months at a time, which they call a term. And during that term, you can complete as many classes as you want. So what's nice about that is if I want to get done, like my bachelor's degree or whatever, I'm thinking about going master's. If I want to get that done in a certain amount of time, I can get done in a 6-month period or a 12-month period. It depends on what I decide to do and how much I put into it. I just finished the first term, and in the first term, I completed 8 classes. And no, that's incorrect. I completed 6 classes. I completed 6 classes, and I have about 22 left to go. And my plan is to complete at least 10 classes this term. And that's just my base goal. So that's a lot on my plate. So full-time job, that, and then I'm also trying to do the YouTube thing just on my own free time. And of course, I got a wife, and we have the kids going on in the house and stuff like that. So, I gotta be there for that. So I apologize for the slowness of my videos, but it is what it is. So anyway, I've been doing these live streams, and I've been doing them every week. and I've been trying to do them every Sunday and Wednesday from 6 o'clock to 9 o'clock. Well, not to 9 o'clock, but 6 o'clock and Pacific time and 9 o'clock Eastern time, just so I get everyone involved. And I go as long as I feel necessary. I will go longer if there's people asking questions, and if I see additional viewers. Usually I've been averaging, I think at most I had like four viewers at one stream. And as I've said many times before, I view this channel as like, you know, I have to build it and they will come kind of thing, a field of dreams kind of deal. And I just plan on helping people out free of charge, and I hope to not monetize my channel just because, you know, I hate ads, but depending on YouTube's algorithm and stuff like that, I may end up having to monetize just so I can get my channel out there. But the hope is I don't have to. Maybe word of mouth will help with that. So I have a couple of A+ videos out there. I have a Net Plus video out, and I'm planning on recording some of that content tonight as I do this live stream, and kind of going from there. So, you stupid fly. Anyway, if you're wearing headphones, I'm going to give you a warning right now. I'm actually turning on my extra recording device, and I'm going to sync it up, so that requires me to clap. I'm going to do that real quick. So if you got headphones on, be careful. Okay, that should get me there. So anyway, yeah. So I know I look like a crazy person right now, but I am really trying to kill this fly that's driving me nuts right now. It just, usually I can get them before I start the stream. Today, not so lucky. Anyway, parts of being in Bakersfield, I guess, is some fun stuff. Anyway, so if you have any questions, feel free to use the chat. Obviously, there's not many people in the stream right now, so therefore, if you ask a question, more than likely it's going to get answered. If you watch my videos after the fact, after I stream them, and leave comments in the comments section, I will answer those as well. And you can rest assured that more than likely it's going to get answered because, well, this is a small channel and not many viewers. So again, hopefully build it and they will come. So moving on, what I got going on today is I have been working on the videos. I'm working out of the Net Plus CompTIA certification objectives or exam objectives. And I've been pretty much stuck in objective 1.5. And the only reason why I've been stuck in objective 1.5 is I've just, again, busy and trying to get this stuff going. So I guess the only way I'm going to get this done is to actually do it and do this this live stream as raw as I've planned to do it. That's how I planned to originally do this stream, was raw, and not really have a whole lot like a talking head thing, but I end up doing that anyway. It's kind of stupid. But anyway, so what I'm going to do is I'm going to do the audio and video, hopefully, of the wired topologies and wireless topologies. In the last live stream, I forgot to post the actual resulting video from that because what I do is I post all the live streams so that there's some continuity, not continuity, but you know, for posterity, I guess you could say. And so I forgot to post the last video, but I will post it. And in that video, you'll see that I actually put some of the content together as far as like some of the stuff I wanted to go over in the video that I want to publish for Objective 1.5. And so I plan on doing the actual content during this live stream and getting that going, and of course answering questions if questions come up. So in the video or the content I'm going to try to create today, I'm going to look at objective 1.5, which is compare and contrast the characteristics of network topologies, types, and technologies. I'm going to go over wired topologies. I'm going to discuss the difference between logical and physical. I'm going to go over what a star topology is, a ring, a mesh, and a bus, and also a thing called a hybrid topology. And then I'm going to go over wireless topologies, and in that I'm going to discuss mesh, ad hoc, and infrastructure. So that's going to be the extent of it. If I got a little bit more time, depending on how long I want to do the stream, I guess it's clearly up to me and I guess the one other person watching. We got Daniel. School district in Tennessee. I have my A+ now. I get tech support job in the. Oh, okay. Yeah, I'd love to ask or answer that for you. So you got your A+ and you're wanting to. So if someone's watching this after, the question was, he's an HVAC tech in a big school district in Tennessee. He has his A+, and how does he get into a tech support job in the IT department? So if you're looking to get into a tech support job within the company that you currently work at, it's a good idea to find out who the head of that department is and let them know that you have interest in it. One of the things I taught a student, I worked with a student, he may be on this stream in the future. His name's Jonathan. I've used his name before. He doesn't seem to mind. But when he was taking my class, I was working with Kaplan College. And when he was taking my class, he was a dishwasher in dishwashing for the hospital that he worked for. And he was taking my class and he was really interested into getting into IT, and he didn't know how to quite break in. So what I suggested to him, and it ended up working out, is I said, hey, find out whoever the department head is, because he wanted to stay with the hospital. So I said, whoever the department head is, find out who they are. You got a company directory, and then shoot them an email saying, letting them know that you're interested in a possible position there. That you've been going to school, you got your A+ certification, you're working on your Net Plus or whatever the case may be, and that you would really be interested in getting into that position. And if you're not ready, if they don't think you're ready, sit there and set a meeting with them and actually ask them what you have to do to get to the level that they want you at to consider you for the position. So that worked out for him. What he ended up doing is he first shot, it was a female department head at the time, so he shot her an email, and the email just said that he was interested in, if she had some time, would she be willing to meet with him? And she replied quite quickly and said, yeah, I would love to meet with you, and I would love to meet with someone that has interest in doing this kind of work. And so he set the meeting, and he came to me real nervous. He's like, what do I talk about? How do I do this? And I said, just be honest with her. Sit down with her, let her know what you're doing. Let her know that you have extreme interest in getting into that position, and ask her straight out, what do I need to do to get into the position, or to put myself into the adequate position of where I want to be, So, if you work for a company, let's say a hospital, or in your case, a HVAC, if you're trying to get into their tech department, since you work for the company, it's more likely that they know who you are, being that you've been with the company, if you've been to work on time, if you're a hard worker, things like that. It's going to be easier for you to actually get into that position, okay? Because they know who you are. I mean, when I was teaching at Kaplan, again, we used to have people from outside of Kaplan that owned businesses. Whatever they did, they would come in and they would advise us. And I was teaching a business class, and one of the people that came in owned a cemetery, and one of the students asked the gentleman, hey, you own a cemetery. I mean, how does one get qualified for that? And he put it very well. He said, it's not about how qualified the person is, like that they already have the skill. It's how trainable they are. It's how reliable that they are, and things like that. Willing to learn. I mean, getting into the IT industry, you got to be very willing to learn and very willing to change the pattern of what you've known before. Some people get in the IT industry and they know a certain thing, and they'll stick in that certain thing rather than broadening their horizons. So, I'll give you another example. Let's say you're outside of a company, and you work in your case, you work as an HVAC, and you want to actually get out of that line of work and you want to become a technician, and your company doesn't have an IT department. Well, you can become the IT, like help people out, and maybe they'll find a need for an IT person. Or if that's just not going to work out and you need to look at getting into another company, being that you have your A+ certification, you should really be looking at things like getting into a company in a tech level 1 position. And that's typically a person that's going to be working on the help desk, and or even Best Buy. I know it doesn't sound good. I'm not a big fan of Best Buy, but a company of that sort where you can expose yourself to more of the technology, to more of like actually working with people, and being that you're HVAC, more than likely you've had to work with customers in the past, so that helps. A big problem with the IT industry is a lot of the guys in the IT industry typically do not have very good customer service skills. Like, they're not very used to working with people. So if you have that skill, you got to step up on everyone else. And so what you'll do is you'll like work for a Best Buy in customer service or something like that. I'm talking about the Geek Squad, and kind of get your chops going. As you know, going through the A+, it gives you some of the basics. It basically gets you ready for the hardware. It gets you ready for working with software. But there's nothing like actually putting your hands on and really working in it and just building that experience. For me, I volunteered a lot. So back in 1998, 97, when I was in high school, I became a TA for the computer department, or for the tech department, and just really found a mentor and worked with him, and then just kind of worked my way up coming out of high school. I got my A+ shortly after high school in 1999. And just kind of built on that. I worked for CompUSA as a, not CompUSA, I'm sorry. I worked for Office Max as a customer service manager, and I sold computers. And just being honest with the customer and explaining the components and helping them understand what a computer does and why it's important to get, this much RAM and this much hard drive and what they do. It's all about just building your experience. So I will admit, even after getting your A+, it's going to be a little bit hard getting into the industry, but it's just showing that drive and that determination. And the other thing I would say, and I know this is a long answer to your question, and I hope you appreciate it, but I hope you get something out of it. But the thing is showing the drive that other people don't have. A lot of people expect to get things, and so people are very surprised when someone comes in and they just show the drive. When I go for a job, or when I help someone get a job in the industry, I always preach to them, be the squeaky wheel. Okay, so if you apply for, let's say, a level 1 position, which is really what you should be going for when you're an A+ technician, I always say be the squeaky wheel, and is the fact when you apply for the job, let them have your resume, let them have your application, and like within 24 to 48 hours, call and make sure they got the application. Make sure that your application is in the list. And then, you know, if you get a call to do an interview, you know, be there 15 minutes early and be prepared. Know the history of the company. I can't tell you how important it is to know the history of the company that you're going to work for. The company I work for was going through a rough time at one point, and I applied for another company called Wonderful. They specialize in citrus and the pistachios and stuff like that, Palm Wonderful drinks and stuff like that. And so when I got called for an interview, I not only made sure I kind of knew my own stuff as far as technical and customer service wise, but I also made sure that I knew everything that there was to know about the company itself and its culture. So I looked at the website. I did research on the owners of Wonderful, the Rustnicks. I knew what they did. And so when I went to the interview and they had that question like, hey, do you have any questions for us? I was more able to inform them of their own company rather than asking them a ton of questions. It showed that I had the drive and the want to work there. I didn't get the job, but the reason I didn't get the job, and I asked them, when they called me and told me, hey, I'm really sorry, but you know, I asked them, I said, hey, what is it that I could do better in the future to become a better candidate or to beat out the other person in the future? And the HR person said, honestly to me, she goes, no, you don't understand. You got great marks. You got high marks all the way. The only problem is we had someone internal decide that they wanted to go for the job, and we preach that we promote from within. And I'm never going to knock a company for doing that. I think that when you join a company, if they're willing to promote within and get you up the ladder, that's the place you want to be. If they're building you up, that's awesome. That's how a company should run. That's how managers should work. A manager is not really a person that should be telling you what to do. It's a person that should give you a task, let you complete that task, and help you build up. And if your manager's not doing that, you're probably in the wrong place. So, long answer. I typically go a little bit long on my answers, but hey, I hope that answered your question. If you have any additional questions, I'm more than happy to answer. And if I didn't quite hit something, ask again or ask, and you know, I'm more than happy to answer more questions from you. You're probably my only viewer right now, so that works. So anyway, hopefully I didn't lose you there. All right, so let's go. Logical, physical. So let's go set this up. And I'll keep checking the chat section. If I got another question, I'm more than happy to answer. Do you have any other questions on getting in the IT department? Or did I brush over anything that you still have a question about? Again, I'd be happy to answer that question. So, and I don't think I have a limitation on how many questions you ask, so there shouldn't be any kind of limitation. I'm going to check that right now. So there should be, yeah, I don't have slow mode enabled. I don't have enough viewers to worry about that right now. Cool. I'm glad I got you subscribed. I hope I keep you. Just so you know, I do these streams again on Sundays and Wednesdays. And anytime you have a question, please feel free to ask. That's what I'm here for. And I've always wanted to do that. Just a little bit more just to let you know. I worked for private colleges, and I also worked for CompUSA as a trainer back in the day. But I've worked for Kaplan College and UEI. And the reason why I'm doing these live streams is to help people like yourself, because I got tired of working for companies that didn't care about the students. They would charge the students. My wife is one of them. They would charge the students like $18,000 for an 8-month course, and they get really nothing out of it, or they would get something out of it, or they'd be promised something by the company like, hey, you know, we do interns to hire. The problem with that is there's no guarantee of a job after. It's really bad. So I do this because I'm tired of companies ripping off other companies, or not companies ripping off companies, but companies ripping off students and stuff like that. That's another reason why I kind of suggest UEI, or not UEI. That's a company I wouldn't suggest. I'll never get a job there again. That's why, yeah, cool. I'm glad you like it. I over-explain a little bit too much, but hey, that's what it is. So we're going to go over Net Plus, and we're going to do Objective 1.5, and I'm going to talk about wired topology. So let's go with that. Anyway, let me set up real quick. So awesome. You are actually, other than someone I've known, you are the first one that's actually taken me up on asking a question. So I'm very stoked by that. I will keep you, I will keep your name down as being one of my first question asked persons. If I could talk, if I could speak English, which I'm very surprised, because in the beginning of the stream I was trying to kill a fly. Still kind of trying. All right, so what I'm doing is I'm reorganizing my screen a little bit, because the whole idea is to be down and dirty with this, and I want to be able to answer questions if I got them while I'm showing them. So let's minimize that. There we go. So there's that. We'll minimize this. All right, awesome. So we got that, and very cool. So we should have one more thing to move, and we should be good to go. All right, so I guess I'll do my welcome and go from there. So I'm gonna do this very raw and just go to talk and record, get rid of the logo. We got audio going, and we'll go from there. Cool. Okay. Start recording. Hello, welcome to my stream. My name is Jacob Jewett, and today I'm going to take you over CompTIA's Net Plus. I messed that up. Jeez. Terrible so far. Terrible. Let's try that again. You get to see what I kill myself over during actual trying to record a video. This is fun. Okay. Hello, my name is Jacob Jewett. Welcome to my stream. Today I'm going to be covering Objective 1.5 in the CompTIA Net Plus 10007 certification exam. And this is going to cover wireless and wired topologies. We're going to start out with wired topologies first, and we're going to kind of go from there. So stick with me and we'll get this down. So there we go. I'll probably re-record that because I'm terrible at this, but at least I got a starting point. And we'll go to demo. Ooh, fun stuff. And we'll go PowerPoint. There we go. And I'll key these in later. Okay. That'll be in the video in the end. So. Okay, today we're going to cover Objective 1.5, which is compare and contrast the characteristics of a network Try again. Today we're going to cover objective 1.5, which is compare and contrast the characteristics of network topologies. We're going to start first with wired topologies. We're going to go over the difference between logical and physical networks. We're going to cover the actual topologies, which is star, ring, mesh, and bus. And then we're going to cover wireless topologies, and we're going to cover in that area mesh, ad hoc, and infrastructure. Thank you, Daniel. I appreciate that. Okay, so a couple of terms to be covered is logical topology. A logical topology, as Wikipedia defines it, is an arrangement of devices on a computer network and how they communicate with one another. Also, a network topology, which is basically a physical topology, is the configurations of computer networks. That can be kind of confusing sometimes, just because the difference between physical and logical topology, let's start that again because I'm on the wrong screen. Okay, the difference between, start that again. So that can be kind of hard to understand because the differences between a physical and logical topology is that a physical topology is something that you can actually touch. So if I went out to my network and I touched a network cable, that is a physical device, and that is a part of our physical topology. So it's how the topology is how the actual devices are connected together. Okay, and that can be in a bus configuration. It can be in a star configuration. It can be in a token ring configuration. We're going to go over this. A logical topology is basically how we depict graphically or visually, so we understand how communication is happening, is how the information is actually traveling from the destination to from the source to the destination, and from the destination back to the source of the request. So it can be kind of confusing, but you have to understand that the physical topology is something that you can actually go and look at and understand how it's connecting. And a logical is basically more almost a theoretical. Again, it's kind of hard to explain, but it's how the information travels along the line. Okay, and then next, let's go to, I gotta correct this Stream Deck to actually do this stuff a little bit better. So let's turn that off so that's not on there the whole time. Let's turn that off too. And then, yeah, so front cam. Go back here, demo. All right, cool. We're gonna go, so have a little music that goes between that, fun stuff. Okay, so the first topology we're going to cover is a bus topology. And what defines a bus topology is basically you're sharing, and this is, again, there's two different types of a bus topology. We have the physical and the logical. And so the physical, you will actually have one cable that connects each computer together. Okay, and it can be more than one cable, but we'll get into that later. But it's basically everything on the network is communicating over one shared, what they call broadcast network, or one shared line. So there can only be one electrical signal on the line at any given time. So in a bus topology, typically these computers and server and printer will be connected using what's called a B&C connector. And a B&C connector typically is, it stands for a British naval connector because the Brits came up with it. But it's an interesting looking connector, and I'll pop up an actual picture of it during the video. But all these computers here are connected to the same line. And so what happens is if this computer here tries to communicate, it will check first to see if the line is free, and then it will try to communicate. If it's trying to communicate, if this server is trying to communicate with this printer, when it communicates, every device on the line is going to see the communication. The difference is if that machine, if this machine tries to communicate with this printer, okay, when the communication goes over the line, all the devices on it see it, okay? So they will all communicate. So what will happen is this server will have this printer addressed as being its endpoint that it wants to communicate. And since this computer notices that the communication is not for it, it will say, nope, I don't need that. And this will say, nope, I don't need it. Nope, I don't need it. And what will happen is the communication will go to the intended device. And typically on a bus network, there's things called terminators that are on either line. We talk about that in the future, about attenuation, and we also talk about what they call echo or a repeated signal. That can cause problem on your line. But basically, a bus topology is either a network that shares, it's a network that either shares the exact same line to communicate, or it will be plugged into like a network hub where the communication going to that hub is basically repeated to all the other devices. Okay, so next we're going to talk about token ring or a ring network. A ring network is, you see this nice little circle in the center here. A ring network is literally almost the same as a bus network, only the only difference is, well, there's a lot of differences, but the difference here is the cable will literally connect from this computer to this computer to this computer and so on until it completes a complete circle. And there's really no end to the cable as far as the end point is the actual computer or the server itself. Okay, so what happens in a token ring network, if we're going to talk about the physical side, what happens here is each computer physically is connected to the same cable in basically a circle formation. So it has to complete the circle, and here's why. When we talk about the logical communication of a token ring network or a ring network, this computer, if this computer here wants to communicate with this computer here, it has to go through each system in between. So some token ring networks, I think not some, but most of them, communicate in a counterclockwise kind of form. So what happens is this computer will create its packet and its information and pass it to this computer. This computer, let me change ink colors here. So this computer here is the one communicating, and so the information will go from this computer to this computer, and this computer will go, hey, this information is not for me. So it will then send that packet and that information that it received from the first computer to the next computer. This computer will analyze it and look at the packet and see if it's for it. And since it's not, it'll say, nope, not for me, and pass it on. And this process will happen until it finally gets to the computer that it was meant for, which means anytime this computer tries to connect to this computer, it has to go through 4 other computers. Okay, this becomes a problem in bigger networks because what happens is if this computer here dies, no communication is going to travel past it. Okay, so typically what you'll have to do is if this computer died, you would have to basically take it out of the network and take the cable that connected to it and just bypass it and go to the next computer in the line. Okay, so there's work that goes in the background on that. So let's say that that computer this computer here got the information from this computer and now wants to reply to this computer. So it creates a packet, and that packet will travel to here. The system will say, nope, not for me. Go to here, nope, not for me. And then it'll go to here, and this computer will go, oh yeah, that's mine, and it'll look at it. And when it decides to reply, same thing happens. The whole process goes over again. So again, it happens in a circle communication, as in token ring communication. And if we're talking about a physical topology, each computer, if we're talking about a physical topology, each computer is directly connected to the next, 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 and to the next, and so on, okay? And if we're talking about logical communication, we're saying that the information travels from this computer to the next one in line, next one in line, and next one in line, okay? And the distinction between logical and physical communication is still important here, because logical and the logical topology itself can exist in another physical topology. So again, I'll explain that more detail shortly. Next, we have a star topology. Now, a star topology is typically you have a switch where each system is directly connected to the switch using a separate communication cable. So if you see here, there's ports on here, and so this computer would occupy one port, this computer would occupy one port, and all the communication that happens gets divvied up in the switch. Okay, this is considered a star topology, okay, where there's one central device or multiple central devices, and we'll explain that a little bit here shortly. But then you have each device directly connected to that switch or hub or whatever. Okay, so physically, one line per connection. All right, star communication also exists in a logical setup. So what happens in a logical setup, and I actually have a demo for this stuff, and I'll show it, so hopefully we'll clear up some misunderstanding if anyone has misunderstanding. But what happens in a star topology with a switch when it's involved, if we're talking about logical communication, is let's say this server, okay, we'll name that one, is trying to communicate with this system here, and we'll call that number 2. This server will create a packet and send it to the switch. The switch has a table in it called an ARP table, okay? And the ARP table, when a device is connected to the switch memorizes what that device is. So if this computer here is 3, 4, 5, and so on, in the ARP table, this switch understands what address is each computer. So when the server tries to communicate with computer number 2, it sends the packet down the line to the switch. The switch finds the port that computer 2 is on through its ARP table and sends the packet to that computer. None of the other computers on the network or on the star topology, when we're talking both physical and logical, will see that communication. Okay, they will not see it at all. Only two members of this network will communicate between each other. Okay, and how this works is a switch breaks up communication in what's called broadcast domains, okay? And what it'll do is each port has its own broadcast domain. And so therefore, when you try to address one computer, none of the other computers see it. Okay, and I'm doing this without like a laser pointer, so it's kind of fun to try anyway. So again, so what I'm saying here is when these other computers don't view the communication, it allows for what's called less conflict traffic, or I'm gonna mess this up. I'll correct it in post, but it allows for less collisions on the network to happen. So the other way to describe it too is when you're connecting in a star configuration to a switch, each connection is its own bus, okay, or own broadcast network, as I said before. And that, again, that's logical and physical. A mesh network is kind of fun. This is where stuff gets a little bit more fun. So if you look back at the ring or bus or star, you'll notice that there's one connection per one device. So if I go to star, there's this connection goes from here to here, here to here. So if this computer dies, it kills everything in line, right? But so, and then if we go to the star configuration, if let's say this machine here dies or this communication is bad, what's nice is in a star configuration, all these other systems can still communicate. No one's cut off. Okay, the only one that can't communicate is this if the line is done. Okay, so there's, in the star, out of the topologies that we've discussed so far, the star topology is the most, what they call redundant communication. Meaning if one line dies or multiple lines die, you still have communication with the other devices on the network. Where we get even better is when we have a mesh network. Now this is considered a full mesh, and typically mesh networks are hard to set up, not very hard to set up, but they're definitely expensive to set up, because in a mesh, this is one of those topologies where it's a physical topology for the most part. You again can have a mesh as a logical, but in a mesh network, we're going to have communication directly from one switch to another, to another, to another. Okay, and typically, since it's so expensive, we have a mesh network of switches, and this is where the hybrid comes in, and we'll talk about the hybrid shortly. But if you see here, we have 5 switches, and each of the 5 switches are connected to each other switch. Okay, so each one has 4 connections going to the 4 other switches, which is nice because if we went crazy and we went, oh, I'm gonna kill this connection, I'm gonna kill this connection, I'm gonna kill this connection, okay, we can kill multiple connections like crazy, right? So this is redundant because in this case here, I've killed 5 connections. 1, 2, 3, let me get the height. I've killed 5 connections. 1, 2, 3, 4, and 5. But none of my devices have lost communication. Daniel, in a district network, typically they'll, for the front end network, excuse me, for the basic computer networks, they'll use what's called a star topology. And usually for a server backend or backbone network, they'll do a mix of like star topology and mesh topology. Did that answer your question? Excuse me. Sorry about that if you got earphones on. But the most popular topology to really answer that question is the star topology, because it's inexpensive and you have, it's easy to find an issue with a connection because typically it's either one device or multiple devices depending on what happened. And I believe I have a slide later on where I explain that a little bit better. So going back to the mesh here, since I might need to get a drink of water. Good, I'm glad I answered that for you. I'm sorry about coughing. I need to get some water here in a second. Anyway, in the mesh network or the mesh topology, we've killed 5 connections, but our communication is still alive in each of the switches because if you look, each switch has some path to the other. So if this switch here was trying to communicate with this switch over here, it would just take another route. So if it had a packet that was trying to go for this switch, it obviously could not take this route. It could not take this route, but it could take this route, okay? Or it could take this route, all right? So this is a mesh topology, is very expensive, but it allows for the most redundancy in the network. The most areas that can fail and still keep communication. Being that mesh topologies are expensive, we came up with what's called a partial mesh. And I believe I, again, explain this in a future slide, and if I don't, I can pull it up and explain it further. But in a partial mesh, you'll have a full mesh in some of the devices, and you might have offsite. So this kind of answers your question, Daniel, is if I had a server network, I would want, or let's say a backbone network, I would want that redundant as redundant gets. So I would have that mesh on the devices that are required to have very good communication. And then I would have a star kind of topology set up with the devices that weren't as important. So let's say, to explain this a little bit better, let's say this is city location 1, city location 2, city 3, city 4, and each of those cities I have major headquarters or a major branch offices that cannot go down. But city 3 is connected to a branch office that if it went down for a day, I'd be okay. Okay? If this communication died, I might complain to my ISP, but it's not going to kill the business. Okay? This would be kind of a partial mesh. And again, physically, it's expensive to set up. We can do it through the web, logically through different paths on the web, because the internet itself is humongous and multiple connections. So again, in this, for site B, we have one point of failure. So for site B, we have one point of failure, whereas in all the other sites, if basically for one site to fail, we would have to have 3 connections die at any given site for the sites to fail. So if this site here completely failed and this connection was gone and this connection was gone and this one was gone, 4, 2, and 3 could still communicate. Don't worry, I'll get off slide hell here shortly. Okay, so in this we've talked about the physical and logical wired topologies. We've talked about bus. If I could get my laser. We've talked about bus, we've talked about ring, partial mesh, star, and mesh. understand that each of these topologies can communicate via physical and logical routes, being physical, actual cable that you could see connecting one device to another, and logical, just the transfer of data. Okay, so if you're going through the Net Plus exam, they're going to ask you the difference between physical and logical, and the difference between physical is it's an actual thing that you can touch, and a logical is how you help interpret how the data is transferring through the line. Okay, and so in that Net Plus exam, they will ask you for logical topologies, and logical topologies include all of these topologies together. Okay, these are all logical topologies. But if they ask you what a physical topology is, it's typically going to be three of them. It's going to be ring, bus, and star. Okay, physically, usually that's the ones that they look for. Can mesh be included? Yes, but typically they don't because it's very expensive. Bus and ring are, they are and they're not. On server backends, there are still systems that are using a ring setup, especially if you have a cluster setup. So if you have multiple servers connected together and they have to stay basically synced with each other, you'll have maybe not a physical ring topology, but you'll definitely have a logical ring. So it'll be connected to a switch or connected via fiber, but bus and ring still exist. And what's funny is when I was going through my Net Plus and initially going through training on this stuff, I was told two things. I was told that ring and bus were going away, which they're not. They're still there. They're obsolete to a point, but they're not really. They still exist. And I was told that IP version 6 would replace IP version 4 because by 2001, I think it was, by 2001, we were going to run out of IP version 4 addresses. And that's obviously still not happened. We still have plenty of IP version 4 addresses available, and they're well managed. And about the only company that's really using IP version 6 is Microsoft. And basically it's, excuse the expression, but it's basically to stupid proof the connection of computers to a home network. Because IP version 6 is backwards compatible with IP version 4. And so yeah, so it's a misnomer that bus and ring topologies are obsolete because they're still used. You may not see them in the forefront, but they're still used in like data centers and stuff like that. Maybe not the physical ring and bus, but certainly the logical version of it. So don't be don't let someone trick you on that. We've been hearing that for years, and it's just not true. Okay, so the one topology I haven't covered yet is what's called a hybrid topology. And again, this can exist both physically and logically. Here we have a bus topology connected with a star topology. And this would kind of go to answer Daniel's question on this. You can have a bus backbone for your server, like a storage network, and it can be connected to a switch to your star topology. you know, so all these devices on this network here may communicate with each other and may have to vie for time on that line, but that one communication going to the switch would then break up what's called the broadcast domains. And we go further into broadcast domains and gateways and stuff like that later in later objectives. But basically, we're just trying to get idea of how they're connected and how they communicate. Okay, next we're going to talk about wireless topologies. Well, before I continue on, Daniel, since you're still there, do you have any other questions regarding what I've discussed so far? Or do you have anything that you would like to add? And I'll give you a second to answer. Actually, while you're answering, I'm going to get water. One sec. All right, no answer, so that's fine. All right, so going on to wireless topologies. In wireless topologies, we're going to talk about ad hoc, mesh, and infrastructure. And I've included them on one slide, mostly because, oh, awesome. I'm glad you like the explanation. Okay, so we're going to talk about wireless topologies. We're going to talk about ad hoc, mesh, and infrastructure. They are asked about in the Net Plus exam. However, they are briefly asked about and not so. I mean, you have to look at the Network Plus exam as being almost like the A+ exam. So the A+ exam really is just kind of getting your foot into the door of understanding the technology. And the same is for the Net Plus exam. It goes a little bit more detail, but essentially it's just trying to get you to understand the concepts. If you want more detail on how everything works in networks, you're going to have to go for like an upper level certification. And again, those upper level certifications, I wouldn't really look at doing until you've at least had at least a year of experience, because everyone that I know that has done the CCNA says it's a bastard of a test, and it's really hard to get past, and that's coming from someone, well, from multiple people I know that have taken the exam, and they've been in the industry for at least 7 years each. So I mean, it's a hardy test. So again, the Net Plus is more of like getting your foot in the door, just as A+ is getting your foot in the door for hardware. So in an ad hoc topology, each device on the network shares an ad hoc name. So the only requirement to be part of an ad hoc is to have your wireless set up with the same name. Okay, so when you go to, and I'll include this in the actual video, maybe I'll do it here. I don't think I have wireless built onto my system, but anyway, I'm pretty sure I don't. Anyway, in an ad hoc, you set up the network card on your computer to join an ad hoc, and you'll provide a name. As long as this system, and this system, and this system all share the same name, they will communicate with each other. This computer will communicate with this printer and with all the other devices on that ad hoc, and it provides a peer-to-peer connection. Okay, usually when this computer needs to communicate with this computer, it just says, hey, I want to communicate with you, period. There's no need for wireless access point, none of that. when it wants to communicate with the printer, it just communicates with the printer. Okay, this ad hoc network will become very congested if you have a ton of devices on it. So it's typically good for only about 5 to 10 devices maximum. And that's usually about the extent of it, because since they all share the same name and they all communicate over the ad hoc communication, they typically will share the same transmission channel, and therefore if the air is clouded with communication, you're going to have conflicts, and conflicts cause communication to not happen. So if this computer and this computer are trying to communicate at the same time that this computer is trying to go to the printer, it'll create a conflict. And that's not good. I just tried to kill that stupid fly again. I'm 0 for 0 for this stupid fly. Anyway, and I didn't have that slide. So Daniel, what I'm going to do is, since you're still with me, I'm going to show you a previous slide that I created. And let me discard that. Oh, I discussed ad hoc, and I was going to continue on. I'm an idiot. 1 second. Let me get that back up. I'm not done with wireless yet. 1 sec. Okay. Minimize that. Okay, let me get that corrected. I totally airbrained that. Okay, so that was ad hoc. Let's move on to mesh. And a mesh network, or a mesh topology, allows you to have multiple access points on your network. Okay, your ISP or cable provider is now advertising this heavily. So is AT&T. I have AT&T fiber, and they're advertising this. So basically what it is you have multiple access points. That's what my little icon is supposed to be depicting there, is you have multiple wireless access points. They all are on the same SSID. They all have the same password, and so on and so forth. And they basically communicate with each other. And what will happen is, like, this wireless access point here is connected to the actual internet, and it will communicate with each other access point in a mesh form, so that if this computer here is communicating with this access point will communicate with its nearest partner access point, and then communicate with the next partner access point until it gets that communication out to the internet or to another device. So basically a mesh is just multiple access points that communicate with each other to extend out the wireless network. You can also use it to basically provide additional coverage, okay, hereby extending the network. An infrastructure wireless topology. Yeah, honestly, Daniel, I couldn't find a very good symbol for an access point. So I went to Wikipedia and put in wireless and basically grabbed that graphic. I plan on, in the actual video, I plan on having a picture of an access point, and hopefully in the future I have a better Visio representation of what an access point looks like on a network. Typically, an access point on a network is just designated as like an antenna, and I'll show that to you if you like, and like when I'm done with this part. I'm going to show you a couple things, but the one thing I'll show you is I'll show you what an access point usually looks like on a Visio. I probably should have used that here, but I figured it this graphic would be a little bit better. In the last wireless topology that we have, I gotta do water, one sec. So in an infrastructure wireless topology, typically the wireless access points are connected to a switch or a controller. Okay, cool. They're connected to a switch or a controller. So let's say this right here, instead of being a switch, is a wireless access point controller. It will be physically via wire, that's why I have these lines here, like a Cat5 cable or something like that. It will be directly connected to each of the wireless access points. All these access points will have the same SSID and the same password to get on them. In the simplest form, you can do more complicated networks, like you can have multiple wireless networks at which all these access points are a member of. But basically what it is it's so that you can add coverage to a building and have a user walk from one part of the building to the other part of the building and never notice that they switched networks. Okay? To the end user, they would never know that let's say they're in a high-story building, they would never know that going from floor 85 to floor 25 that they switched wireless access points, because this system here, usually a wireless access controller, will actually control or do the switching from this access point to this access point without the user knowing. Okay, so again, we have ad hoc, where each wireless device on the network communicate directly with each other. We have mesh, where multiple access points communicate with each other to provide service or extend a network. And then we have infrastructure, where all the access points are centrally connected via a controller, and they provide wireless services throughout the network. All right, so next I'm going to go through it depends on what AP you're talking about. So like if you're talking about like a home network, then your AP could be your wireless router. So being that it could be your wireless router, it typically a home network, you'll have your modem from your ISP that connects into your router, and then that router has antennas on it, and that provides your wireless to your home. In a infrastructure, typically, for the company I work for, we have a big warehouse. The only way you can get communication to actually work through APs is to have them go back to a switch or back to a controller. So there's different types of controllers. There's controllers like Cisco has a controller where you have a base station, and then all the APs are directly connected to that base station. And then you have for a school, they will more likely have a controller of some sort. So yeah, they would be connected from the access point. It'll be connected usually using what's called PoE, or Power over Ethernet, so that they don't have to run two cables to the access point. They'll run one cable, which is a Cat5 or a Cat6, to the access point, and using PoE, they'll power that access point over the one cable. And that is typically, yes, physically connected to either a switch that has a server on the back end that's actually controlling the communication between the APs, or it'll have a AP controller or infrastructure controller. So essentially the APs would be dumb APs. Basically all they are is like a antenna, and the controller is actually doing all the communication. But there's different systems from like Cisco and Aruba, and they have different solutions. So it kind of depends. But yeah, typically they'll be connected hardwire to a switch. If you were to do like a mesh setup in a school with APs, I mean, once you get past like 10 users, that thing will be like over congested, and there'll be a lot of conflicts in the air. So glad I can answer that question for you. Okay, let me show you the difference between, I'm going to explain bus and the bus topology and the star topology to you, but I'm going to do it through visuals here. Give me a sec here. Let me open it up real quick. Absolutely, I'm happy to answer any question you have. All right, let's do star bus. Yeah, that'll work. Open that sucker up. Give it a second to open. Open. Kind of slow on the uptake here. There we go. All right, so I'm going to go to demonstration screen here. So we're going to go OBS, demo, switch from that to PowerPoint, and let's see. All right, so we need to move that up out of the way. There we go. Sorry about the tunnel vision there. All right, so the first thing that we're going to do is we're going to do a star topology. So what I've done is I'm using a tool called Packet Tracer. And I guess I could get this out of the way and make it bigger for you too. Okay, so I'm using a tool called Packet Tracer. And this is a free tool from Cisco for people trying to learn networks. And what it allows you to do is take basically a theoretical object in your head and make it, you know, somewhat real. So what we're going to do here is I'm going to pull up that, and what I have here is I have a hub, and basically I have a star physical topology, so a star physical topology with a bus logical communication. Okay, so a star topology with a bus communication. So what you should see is if I try to communicate with one of these systems on the network, you should see that all the systems see the packet because this is set up as a bus. So this is how Cisco, for you Daniel, I won't include this in the video, but this right here is how Cisco identifies a wireless access point. Okay, so if you see this, this indication here that by Cisco standards, that is a wireless access point. And hence the dashes. So there's physical communication. We have physical communication going from this system to the hub, this system to the hub. And if you look at it, if we look at the actual hub, you'll see that there's supposedly physical connections there. And if I were to delete a connection, say this connection. Oh, nope, that's not what I wanted. Undo. Okay, so if I want to delete this connection right there, when I go to create a new connection for it, you'll see that when I click here, it asks me what port I want to connect it on. I'm going to say fast Ethernet. And when I connect it to the hub, I have to pick a port. So they're direct connections port to port. And then the wireless, there's obviously no port for that. Okay. So in this communication, we're going to show the difference between a star topology and a logical communication. So I've cleared this out on this side, and what I'm going to do is I'm going to open this up, and I'm going to say I want it, this system here, I want it to ping another device on my network. So I'm going to open up, and I'm going to say ping, not penned, ping 192.168.1 and 03. So 103, that's another computer on the network. Oh, .1 dot, so .1.103. And I'm going to ping that. And so since this is a demonstration, it holds on to that so we can see what happens. So I'm going to tell it that I want to capture and move forward, and we're going to actually see how that packet travels. So when I hit go, this computer is going to send a request to ping a system, which unfortunately is itself. Apparently, let me redo that. Okay, nope, I was right. So it's going to ping a system on the network that has, oh, it is itself. I'm an idiot. One sec. Yeah, yep, it was itself. Yep, that's it. So let me, I'm an idiot. I picked the one thing that basically it's just pinging itself. That's beautiful. So let me reset simulation. What's this? IP config. Ah, typing with nothing. Yep, that's exactly what it was. I told it to ping itself. Okay, so let's have it ping the server. So, okay, so we're going to tell this to ping its server. So you're going to see that packet start here. We're going to tell it to auto play, auto capture. So this will tell us all the steps that it takes to actually communicate. So we're going to say autoplay, and what you're going to see is that packet goes to the hub, and the hub will repeat to the broadcast domain every system connected to it. Okay, so this is a logical bus communication, because the logical in a logical bus, all the systems will see the communication. So what I did was I said that I wanted to ping the server. So in pinging the server, if we look at my screen here, I am sending a ping out, and you're currently watching the packet go from my requester to my destination, and my destination replying, hence this line here. So this server is replying, and you're seeing it. But since this is a logical bus network, every time this communicates and goes through the hub, every device will see it. Every time this responds, every device will see it. Okay, that is a star physical topology, okay, with a bus logical topology. Okay, so now that we've seen that, we'll go ahead and close that. Is there a close on this? There should be a close. No, there isn't. Oh, shoot, we'll just close it. Was it helpful? I hope it was helpful. Okay, now going from the bus communication, we're going to what's called a star-star topology. So we're going from a hub to a switch, okay? And what's nice about this is when we communicate with our server this time, we are actually going to see that the initial communication, as this switch learns the network, this communication will go out to all the other devices. But once this switch learns the network, the communication between this computer and this server will only go between each other. What a switch does in a star topology is it separates the broadcast domains. So each one of these is a broadcast domain. Okay? So what I'm going to do here is I'm going to go to my desktop again, and I'm going to ping my server. So ping 192.168.1.10, okay? And I'm going to tell it to do that. We're going to see that that packet starts, and we're now going to capture it. So what we should see is I don't know why it's doing that. It should just send out that packet. It probably doesn't like it for some reason. Is it down? That might be it. One sec. I wonder if I turned off that system. So let's stop that. Sorry about the messing up here, but it's free, so I guess people can complain, but it's free. Let's see. If I remember correctly, this was config, yeah, 192.168. Okay, and here. Oh, it's probably because the switch didn't recognize it yet. That's probably it. Timed out. Let's try that again. There we go. Yeah. So the switch didn't recognize devices yet for some reason. Okay. So again, we're going to watch a ping go from this system to the server. And this time in this demonstration, we're using a star physical topology with a star logical topology, okay, where each broadcast domain is different, okay? Every one of these is a broadcast domain, and that's what the switch does, is it separates them out. So we're going to see this capture now. So we're going to watch the packet go from this computer, if it actually captures, there we go, to the switch. And if it memorized the devices so far, it'll go straight to the server. Notice that none of the other devices on the network saw the communication. It was just from this system to the end device and back. Okay? So this is a star physical topology with a star logical topology. If we were to, again, reset the simulation and start again, and I forgot the IP of this machine, so let's find that out. IP config. And it's, in this case, that's .3. All right, so in this one, we're going to ping 10.168, not, sorry, 192. I can't type tonight. My voice is going and I can't type. Okay, dot. Okay, and we're going to ping that machine, and then we'll watch again. So in our last communication, we saw the communication between this system and this server. Now we should see it go across wireless and all that stuff without talking to any of the other devices. So watch that packet go from our source machine to the switch, and then it should follow down. So this access point is also acting as a switch, and it'll know to send it out here. Now, the thing that's important to understand is this layout right here is technically a star physical, a star logical with a bus topology, okay? Because wireless is actually a bus topology, because everything that goes over wireless is on the same broadcast domain when the channel on this wireless and the channel on the laptop are the same. So they are, again, they are a bus system, okay? So any communication that goes over this line, anything that's wireless over here is going to see it. So if I added more wireless computers and had them communicate, you should see it go across. And I might do that in a future demonstration. But that again is demonstration how you can have the same layout, a star topology, and just by switching one device, you can go from a bus logical to a star logical. And that is gonna be pretty much it. I might do more additional recording for the video, but as far as that is concerned, that's pretty much it on that. What I will do, since you've been a trooper and hanging out with me here, Daniel, I will pull up one of my other presentations and show you kind of how some of the topologies work together here. Excuse me. Let me go. I don't have anything I'm trying to hide, so we should be good here. All right, so let's go to types. This should show, okay. So Daniel, this was in my first video. So if you go back and you watch my previous video where I went over the first parts of Objective 1.5, which is the types of networks. In that video, I cover LANs, WANs or WLANs, MANs, WANs, CANs, and SANs, PANs. In that video, I had many layouts as well. And I believe one was wireless, and I kind of messed with it. So to answer your first question that you asked about, it may not have been your first question, but you asked about wireless access points and how they're depicted in Visio. Unless you have what they call a, unless you have a sketch, I'm gonna mess this up, but unless you have the Visio image of the actual wireless access point, typically they're indicated by like an antenna. So here I was trying to depict a home access router, and typically in a router you'll have the router capability, which is like a switch, a built-in switch, and a firewall, and it'll also have a wireless built-in. So it's this little antenna thing here. So that's to your first question on access points, I believe it was. And then here's the idea of how something can be connected via two different topologies. So we have basically a star topology down here, and we have the internet connected to the firewall connected to the router, and this was just a very simple drawing, and the router connected to the switch, and then it communicates to your server network, which on the back end, you may have a mesh set up for your storage. So you have your SAN storage network, which typically is set up as a mesh. And the reason why you would do that is because if one storage container fails, you want your users to still have access to your other storage containers. So the way this mesh is set up is if one switch failed, the other switch takes over. If one communication between your file server or your Active Directory failed, you would still have multiple different paths, okay? And so sometimes between storage devices, you'll have like a bus set up, especially if it's fiber. So on a fiber network, communication is faster and also is less susceptible to conflicts. And if there is a conflict, it gets resolved so fast that it really doesn't matter. And if you're using a true fiber network, for example, if this is an actual storage device and this is an actual storage device, these will be connected directly together or direct to each other via fiber. Okay, so fiber from here to here and here to here. Okay, and that would be like your bus. And if you had it in a circle and it was sending the communication in a circle, that would be a token ring network. Hopefully that helps clear up some things. So how people set up their backbones kind of depends on the demand of the business and what kind of communication they need. All right, and I think that's about it for this one. I've been going for almost 2 hours. It's definitely been fun. To the one person on this stream that's been asking all the questions, again, if you're watching this video after the stream, please feel free to, again, leave questions in the comment section, because I do look at them and I do answer them. But I'm gonna ask the one person that's been on the stream the whole time, do you have any additional questions? Feel free to ask anything. I will sit here for a minute or two and let you ask away. Ask anything on the industry, anything I've covered tonight, anything I previously talked about. Network types is perfect. Thank you. I hope you like that video, and I hope you like the video I'm gonna come out with this one. I need to get to better shooting. The next live stream is gonna be this Sunday. Well, it should be this Sunday at 6 o'clock if I get home on time. I'm going with the family to basically go see a decommissioned aircraft carrier, but it should happen this Sunday at 6 p.m. and that's Pacific Standard Time. So I don't know if you're West Coast or East Coast, but if you're East Coast, it'll be at 9 o'clock Eastern Standard Time. So, and of course Central is right in between. So, you know what, 8 o'clock or whatever Central. So yeah, I will hopefully stream Sunday. If I don't, I'll be back Wednesday at the same time at 6 o'clock and go from there. So far out of doing all these live streams, I've only missed 2 streams. I've been doing it for about a month and a half now, maybe a month. And yeah, so I've only missed 2 streams. So yeah. Ooh, Tennessee. I have a friend that's I work with a guy that's from Tennessee, and there's a possibility I might be joining you on the East Coast. I don't know if I'll quite go to Tennessee, but I'll be going past that if everything goes as planned or as I hope. So anyway, I look forward to seeing you this Sunday at 6 o'clock, and I will hopefully be further along And I'll announce on the stream, I'll announce before I do the stream what I'll be covering, and hopefully you'll join me and have more questions, or even invite some friends. I would like to help out as many people as I can. Again, I'm doing this for free, and I just like to help everyone. Yeah, hey, if you want Packet Tracker, matter of fact, I'll show you how to do it. Well, I don't have the time to do it right now. Maybe that's what I'll do on Wednesday. I think I covered it also in another stream, but Packet Tracker is a free piece of software from Cisco. You have to go to Cisco Education and sign up and basically say that you're studying Cisco certifications, and they have a bunch of practice things on there for you. And one of the things they have on there is Packet Tracer, and you can download it and you can play with it. You can conceptualize networks. You can do all kinds of stuff with it. It's been a free tool from the very beginning, and it's very cool. All right. Thank you very much. I hope you have a great night. Until Sunday, I'll see you then. And bye for now.